Yo, 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 yo. Piers will find that funny. It's a throwback to somebody I was pictured for a while actually. But Piers, I always find that hilarious that guy did that on that stage. So, hello everybody. I am back from the COVID again, which is a bit annoying. Seem to keep getting this thing. Um, but it wasn't as bad as before, which is good. Um, so yeah, what are we doing? Let me think. I'm still a bit slow actually. I'm not the brightest spark in the box today. This took me a bit longer than I thought it was going to take me. So a few days back, somebody posted me a link to a Twitter Spaces conversation between I hope I get his name right. A chap called Richardson from Exodus and SBF. You know who SBF is. I think there's somebody else in there as well, and they were talking about a bunch of stuff. It's quite interesting about FTX and various things that have moved to the Bahamas. Very jealous. And then just like crypto stuff and layer ones and all this kind of thing. And SPF made a interesting statement, which I've heard a few times actually, not just from him. Quite a few people have said that not only would story movies and stuff on a layer one be a stupid use case, which yeah probably it wouldn't actually be possible to do, which I've always thought is a bit I don't believe that. So I had a little think after I'd listened to that Twitter Spaces podcast thing. I thought, you know what, I reckon I could do this quite easy on Cassandra because most of the stuff that I need is already there. The the state model, the sharding model, etc., lends itself to load balance this stuff out very nicely. So I figured I'd have a crack at implementing some media streaming stuff. Now I wanted to make a nice DApp for this. I wanted to make a proper Radflix DApp. So it's a bit like the App Store, and you could have like different things to click on and play. But as always, iOS and Safari decided to fuck up my day. So I haven't got that far. But what I do have is I can stream media, right? So I've got a little setup. I've got the DApp Store, but I also wanted to do this under some load as well. So of course I've got a Twitter import going at the same time because why not? Just to flex a bit more than usual. And it's all it's all doing its thing and stuff. And I've only just started it, so there's not much there. But it's doing its Twitter thing, right? It's doing importing media. It's importing profile pictures, banners, tweets, all the usual stuff. And then alongside that, we're going to import in real time some media, and then we're going to play that media in said browser. And I'm also going to give you the links in the Twitch so you can go and look at it too. Hopefully, iPhone Safari stuff behaves itself. I haven't tested it much. Obviously, not much time today. Tested it in Chrome, tested it in Edge. Seems to work. And obviously Safari, but let's not hold out any hope for Safari being reliable. And then I got a bunch of things already up in tabs, so I can do MP3s as well, not just videos, obviously. So I've got some stuff here ready to go, and obviously it's not there, right? Because I haven't imported this stuff yet. So let me switch to my console. So switching to beer is a good idea. I would switch to beer too, but I got to drive home very soon, so not going to be doing beer. Have one for me, please. So what have I got going on? So first thing we're going to do, let's just put some MP3, right? So I've got a command here that runs the hosting CLI command and tells it to convert this MP3 into a stream and stick it at rad sounds duck and cover 320.mp3, right? So we hit that, it's doing some uploading. It's about 16 meg, this mp3. Off it goes. we won't be able to tell what's going in because there's tweets and all sorts going in here as well. So we can't see directly what is going on, but that's probably there by now. Can you hear that? From the Rad Sounds Telegram group might recognise that tune. So then you guys can go and play that. That's actually one of my tunes that I made many years ago. So okay, let's put up a video. So let's put up a movie trailer. I've got a couple of movie trailers, and then I've got a kind of short film. Hopefully there's no copyright issues with it. I'm assuming this short film I'm going to put up is I'm allowed to do it. If not, then well, I'll have to have a conversation and take it down maybe. Anyway, so here's a video going up. This one is 32 meg. It's only a movie trailer, right? So it's not going to be huge. And then we'll also put the Matrix trailer up as well. That's like 20 meg because the quality's a bit crap. So give them a little while. They don't take too long. And let's go back to this. Now if I go here, we should hopefully have... in a minute. Hold on, it's taking its time. It must be missing a chunk somewhere. There we go. Movie trailers. So we can at least host movie trailers, right? And you can do skip. That was a bit of a pain in the ass to do, actually.
Have you ever had a dream?
To skip an unbuffered area at the start.
A human being put air to everyone who has fought an agent has died. But where?
There you go. And then here's the other one that I just put up, which is another favourite movie of mine. It's got some weird preview thing on it. I'm not sure what that's about. Where are you? Here we go. If you all haven't seen this film, you're really missing out.
People should not be afraid of their governments. Governments should be afraid of their people.
Very good feature.
Excuse me, miss.
I'm sorry.
Not yet.
I was thinking
And they created a monster.
so that's pretty cool. And then so they were fairly low quality, right? I think they were like 360p because they're super old trailers. Now this one I'm going to put up now is a 1080p short film. It's about 9 minutes, I think. There's actually 7 episodes to this, so from what I've watched of it today, it looks quite cool. So I might get to the other 6 episodes and watch it. This is 70 meg. It doesn't take too long. So what's going on behind the scenes is this CLI command is chopping this up into chunks of about 1 megabyte each, and they're being submitted to the network, and each of these chunks is living in a different shard. This is quite a small network, so I've got 8 shard groups running, but you know, a piece is going in one of 8 shards, and then when I want to stream it, then I pull a piece, and then I pull the next piece from somewhere else, and the next piece from somewhere else, and then the browser does all the. Well, there's a transformer behind that's putting all these pieces together in like a HTTP stream. And then the HTTP stream goes to the browser, and then the browser plays the thing, right? Now, if I want to then skip to 3 minutes in, then the browser sends the whole the range byte stuff for HTTP streaming. If you're a web dev, you'll know what that means. And then my transformer in Cassandra takes that range content byte index and figures out where it's got to go and look for that in the network, goes and gets it, gets all the chunks, etc., puts it back together and sends the stream out. Now, on top of that, what's also enabled here is the data sharding as well. So when we're playing these, each of these chunks has also been data sharded as well across the shard space. So we've kind of got 2 layers of sharding going on, and then all that's being fetched, recombined, and sent to the browser, and then the browser plays the stream, right? And so obviously we've just been clicking around on that movie stream, and you can see how responsive it is. And the setup here is this is a remote desktop to one of my Cassandra nodes, but then my browser is running locally here. This machine's over in Europe somewhere, and then I've got my browser that's running here, right? So eat, sleep, work, repeat. Would you expect anything less? So we've got all this kind of sharding stuff going on, and then the chunking of the data and the fetching it, reassembling it, sending it to the browser, and it's all just nicely load balanced, nice and efficient as well. So that's gone up, right? So let's have a look at that one, which is here. Pretty cool, actually. Skipping around and stuff. So this one's like a bit higher quality, and you can see it's still responsive. Pretty cool effects in this as well, actually. I do recommend it. Watch. In fact, any of the Dust short sci-fi films are quite good. Can I do some live? What do you mean? I can't stream live yet. I'm going to do that next weekend. So what I want to do is do a live stream, like this Twitch stream, push that onto Ledger, and then be able to view that with a little bit of latency on the other end as it goes on Ledger when it comes off. I expect about 10-15 seconds of latency. Like unprepared. Well, yeah.
Trouble crew, this is Officer Cole Freeman, initiated manual override to come aboard your vessel via off-work government. But
yeah, I mean, I've just pre-prepped this a little bit. But if you want if somebody wants to send me a video to push on Telegram or something, then I'll push something on. So that's kind of most of where I'm up to with this, right? And then I thought, well, what about one final flex here, right? Let's push the envelope a little. So this next one is a 4K version of that short movie that I've just been playing. And this is quite a bit larger, as you can see, like 312 meg. So this will take a little while to go up. I mean, it goes quite fast. I think I'm feeding these at about 4 or 5 megabytes a second. But this is a 4K stream, so obviously the amount of load on the back end, fetching all these chunks and pieces and putting them back together again, is quite a bit higher because it's 4K, right? It's doing basically 4 times the amount of work for the same amount of stream time. So like if 1 second was a megabyte, then now 1 second is like 4 megabytes, give or take, right? So the load on the back end is a lot more. And again, wanted to see, okay, can we stream out 4K, and can we do it efficiently? Can we do it quickly? And then while I'm watching this on here, I'm going to drop the link into the Twitch stream box, and you guys can go visit it at the same time as me, and we can see if we get any glitches or any bufferings and stuff like that, which I haven't actually tried. So because I don't have enough machines to hit it with. So you guys can help me break this right now if you're feeling up to it. Okay, so while that's doing, let's just make sure that all of our wonderful Twitter stuff is still going off, which it should be. Yeah, we got some more Bitcoiny stuff in and whatever. So I mean, this is under load as well, right? This is doing Twitter imports too, and then we're pushing this media up and quite large kind of streaming stuff and everything, and we can stream it at the same time.
From that dream, how would you know that?
Play around with things.
And we are the cure.
Hopefully, that 4K will be done. there you go. So this is now a 4K version of that short, and there's the link if you want to go and click around it a little bit and give the back end some load. Let's see what goes on. What we're looking at. So yeah, I got quite a lot of send and receive going on. Oh yeah, let me mute that vid. So this is playing. Are you guys? Is it working for you guys? That link? And your 56K. I would imagine that it probably would lag a little bit on a 56K, seeing as it's a 4K movie. Oh, for a second or two. I am sorry. You know, that's still better than Netflix when you click play, right? Even with the 4K stream, clicking around is fairly responsive, which is cool. So, what have we just pushed? What, a gig of stuff to the network. We've got tweets going in at the same time. We've now got multiple clients viewing these videos. And the network's only small as well. There's 8 shard groups, 8 machines in each, so there's only 64 nodes in this little network. So I mean, yeah, you throw enough load at it, it probably will start to get a little bit glitchy, a little bit slow. But once you scale that up, right, once you've got a few hundred in each shard group, it all get load balanced across them, the requests and everything, and then once you have a greater number of shard groups as well, then the amount of data that each one of those shard groups will be having to serve and hold and fetch and respond to and stuff will be less as well. So skipping on ledgers faster than skipping on my hard drive. Well, that's good. I'm glad we have fast skipping. So yeah, I mean that's my day's work today. Really, I mean there's not a lot more to show, but hopefully that's blown some minds in the Twitch stream today. Do we have any questions about this impossible stuff that's not actually impossible? Let me have a look, actually. What we got in the chit chat? Solana down Cardano one day for Dex swap. It's 4K video. When you put it like that, when Pappers. Yeah, I keep moving away from doing the Pappers because I'd rather show this stuff right now. I think it's a bit more exciting. But I do need to finish these Pappers. 8K. Can someone send me an 8K video? I'll throw an 8K video up there. I'm sure it'll do it. So Twitter is obsolete. Netflix to the garbage as well. Yeah, unlike this is showing like you could do YouTube too, right? I mean, I keep going back to that to the whole question around why would you store all this data on an L1? And if you forget about the economics of it all, then the question is really, well, why wouldn't you, right? If you have an L1 that can, then forgetting the economics, forgetting like state rent and all that kind of stuff, why wouldn't you store this stuff on an L1 that could? Otherwise, somebody's got to store it somewhere. So you're going to have like a secondary file system like IPFS or something like Filecoin or Store or Arweave or something, right? Somebody somewhere has got to store this stuff. So in the sense where you didn't have any economic headaches, then you could. There's no reason you couldn't, especially with all the data sharding stuff going on, and where a 1 gig video costs 10 kilobytes per validator set, right? Per validator. So you definitely could. So that's kind of what this is really showing is that you could do a Twitter, you could do a YouTube, you could do you could do live streaming stuff, and you could do Twitch, I guess, if you were willing to accept the latency between the feed going to the ledger and then being able to stream it back off again. So you could, if you didn't have an economic nightmare, why wouldn't you put your media on an L1? Obviously, you add economics into the mix, and then it starts to get a bit more complicated. But even then, somebody somewhere's got to store this stuff. So there's got to be an incentive somewhere for somebody to store it. So sometimes I feel like the whole, oh yeah, we'll just have a reference to some video on a distributed file system somewhere. So, well, who's paying for that then? Where's that going, right? But then the argument here is that this was impossible to stream off an L1, and it clearly isn't. I mean, yeah, somebody could do an OnlyFans. I'm sure somebody would do an OnlyFans. I mean, what are the limits of this? I don't know. I haven't really pushed it. I suppose your limit would be the ingestion rate of the network, right? So if you were pushing stuff, if you were uploading content, a lot of content was being uploaded, then you would hit a bottleneck at some point, because there's a certain amount of data that can be ingested to the network per second, right? And that's a product of how many shard groups you have, how many validator sets you have as well. So generally, a single validator set can ingest reliably in Cassandra right now between 20 and 40 megabytes a second. So with an 8 shard group configuration, as I am now, you're looking at 160 to 320-ish megabytes a second that you could push onto Ledger. Obviously, if you had more shard groups, then you could do more, right? Obviously, 320 megabytes isn't anywhere near what YouTube has to chew through every second. But if you were to have like a few hundred shard groups with a few hundred replicas in each shard group, then you'd probably be getting fairly close to being able to support a YouTube, for example, and pull all that data in. Now, the delivery rate of the network is much higher. So if I'm retrieving stuff from the network, then that's a product of what your kind of baseline network connection is on your kind of median nodes, right? So you've got some long tail of connection speed. You've got some very fast nodes up here, and then everybody else is kind of in the middle, and then you've got a long tail of everyone else who's slow. And so your retrieval bits per second basically is kind of in the middle of that curve. So if the average is say you got 100 megabits per second sits in the middle, then you'll be able to pull out about 50 to 60 megabits a second from that particular shard group from a single validator. So if you have many validators in there, then different clients will be hitting different validator endpoints, so you can actually pull out a lot more, because you're looking at say 50 per validator. But if all of the validators in that group are being touched, then you can actually get a lot more out, because then it becomes a product of the number of validators that are being asked for stuff by clients, and what the kind of mean connection rate is that everybody has in that group and in the other groups as well. So the math for that starts to get a bit complicated, but you can pull out a lot more than you can put in. Yeah, we should probably try and get SBF's attention, which I'm going to try and do. Oh yeah, and then like a file size limit, there is no real file size limit here. It's just whatever. So I could put gigabytes and gigabyte size movie, and I could stick a Blu-ray on here or something. Obviously, it'd take a while to upload it, but you could put it on. Can you host a Papa song on Cassandra? We already did that. It went up on a previous Twitter demo. I should definitely put it back up. How many simultaneous streaming requests could the nodes handle? Well, we just kind of touched that, right? So these connections right now have 100 megabits, each one of them. So, I mean, yeah, you could probably serve 3 or 4 clients on each, serving that 4K movie before you start to hit problems. How many nodes are used? There's 64 in total, 8 groups of 8. So yeah, the fee stuff. Will it be expensive in fees to upload store on Xi'an? Well, yeah, no. Who knows? Probably not. Probably yes. It's the economics thing. Not really looking at that. I mean, like this is just technological prowess, right? Look what we can do that you said couldn't be done. Only Dan's. I like it. Let's go. Metaverse side. Metaverse, Facebook. I mean, there's this whole metaverse thing. Yeah, I don't even want to think about Facebook and the metaverse right now. Ooh, download the Twitch stream and then push the Twitch stream onto Flexathon and let everybody watch it on. That's a fucking great idea. That is a great idea. Yes, we'll do that. We'll definitely do that. I love that idea. Yeah, okay. Hey, why don't you go and watch this Twitch stream that's talking about serving heavy media from an L1 ledger, and go and watch it on an L1 ledger. Yeah, okay, we'll do that. Anybody want any of the other links while I'm still here? There's the Matrix one. You got Duck and Cover already. There's a V for Vendetta. And there's the non 4K version of that other thing. Simple TXs are freezing while Cassandra runs movies and all other features. I mean, it's not. That's not a fair statement, really. I think, because Solana's a live mainnet, and this is just a research mainnet, so it's not operating in the same way, under the same environment, the same conditions. So I don't want to be too harsh, but I'd like to see Solana do this, right? Or Avalanche, or Aulong, or what's the other one, Cadena, or any of them guys. And share the link to the Impossible guy. Well, yeah, we need to try and get SBF's attention, and the Richardson guy who hosted that Spaces. Cardano. I mean, there's nobody that I'm aware of, and even in the top 100 that could do this demo, what we've just shown, because they're just not built generic enough. That's the real power of Cassandra. It's the generic state model, right? It's the generic and abstract way of dealing with content. Like the state model in Cassandra doesn't care what the stuff is. It's just, okay, I got this stuff, it's some bytes, it's referenced by this thing, it's associated with that thing, where's it living? And that's it. And then you just come to some consensus on that. And then if you're actually executing something, you've got some allowed transitions, and the execution deals with if it's allowed or not. The execution cares to some degree what it is in terms of a transaction or a tweet or whatever. Excuse me. But all the execution model really is doing is just this stuff. It's like mega simple. So if we're looking, so these things, right? Can I zoom this in easy? I don't think I can. But basically what this is, like this is the entire execution engine basically. I mean, you can put some logic in here as well, but basically what you're doing is just monitoring these states, right? It's saying get this thing, this state address, and this state address must exist, or in this case, it must not exist. And if that doesn't evaluate to true, if it can't be found, and it does exist, or in this case, if it doesn't exist, then it'll fail, right? And you can express, well, so far I've been able to express everything with this simple state model. So the instructions, there's 4 instructions that drive Cassandra. That's it. Exists, not exists, get, and set. That's it. There's nothing else in the execution layer that's changing state, right? Now, of course, I've got other stuff here, right, where I'm saying, I'm doing like do the owners match, or is there an ancestor or something, right? So I've got some value from somewhere that's been pulled from the ledger, and I'm saying, does this equal this thing, or does this equal something else, or is it what I expect it to be? Is it in range? Is it a negative number? Is it a positive number, etc.? But from the ledger point of view, all I'm then doing is writing that back, right? I'm doing what I'm doing to it, and then it's being written back as everything's a uint 256, and so it's just get this thing. Does it exist? Does it not exist? And set. And that's everything on the state model point of view. That drives the transactions. That drives all the tweet state, all the media state, where things live, everything. Just those 4 instructions, and then you just got these 2 different state objects. So a state address is something that's unique, right? So in this case, the endpoint of one of those videos, like the matrix URL. So there's an endpoint, and that endpoint is a data resource that's unique, right? So this state address says create a state address out of something that's a data resource and that has this endpoint URL. Hash that endpoint URL, and that's then the state address, and try and fetch it from the ledger and make sure that it doesn't exist, because if it does exist, then someone's already uploaded something to that address. And then I can do counters, right? I've then got a state field, which is a piece of state that holds an actual value, like a counter. So in the case of the Twitter demonstration, there's a state field that is associated with a tweet ID, and its field name is replies or retweets or whatever, and that just increments. Or I can put all the hashes in the state field, or a little piece of byte data or something, right? Whatever I need to store in there. But that's the entire execution that deals with all this. And so that's why Cassandra is so powerful at being able to do these things, and why I can turn these things around so quick. Because all I'm dealing with are these 4 commands, and then these 2 primitives, which is a state address and a state field. And so far, there's nothing I haven't been able to express with that. So there you go. There's a little peek under the hood of Cassandra stuff. Now, obviously, some things I might need to extend these instructions a little for some stuff, but they're easy enough to extend. So yeah. Hey, thanks for all the nice comments in here while I was just talking about that. Thank you. The most impressive demo I've ever seen. Well, I'm honoured to have given you such an impressive demo and to receive this wonderful feedback. Could a future live client? Well, I mean, so the old eMoney client, like the chat, the movies, the games, and such, you can just do all that now with Cassandra as dApps, and you just run them in your browser. So there's quite an evolution away from that old hard-coded eMoney client. You can just do all of this in browser now, and you just deploy a dApp to the ledger, and it all basically just runs from there in your browser or your phone browser or whatever, and a wallet or Explorer and all these things. a decentralized OS. I mean, I wouldn't say it's an OS. It's probably a kernel, maybe. At this low level, you've just got a really tight, specific kind of kernel that is just completely agnostic to the data you're putting across it. So, like from a kind of stack point of view, right? You've just got your state primitives, your state field, and your state addresses, and that's what the ledger cares about. That's what the ledger stores, and then your DAP would have these components. Right? So, like some of these are obviously hard coded in Java, but then I do have others that are JavaScript defined, and then I deploy that JavaScript executable code onto the ledger, so I can deploy these components as well. So these are like your kind of middleware application type primitives, right? So there's some basic logic in here that defines how a hosted data resource in this case should behave, right? And what's allowed and what isn't allowed. So is that slot already taken? Yes, no. Does it have ancestors? So this ancestor stuff here is so I can push updates, right? Which is something else super interesting that you can do with Cassandra really fucking easy. I can just push an update, and the network just knows what the latest version is to get if I don't tell it to get a particular version. So this is kind of like your application primitive logic, right? Just checks that all everything's how it should be and all the fields are correct or whatever. And then what sits above that then is your actual application logic, which in this case, for a lot of things, is some JavaScript that runs in your browser, right? That's the application. And that interacts with the Cassandra network via a thin REST API, which is, again, only like four main endpoints. And through that REST API, you're fetching these bits of state that are required to do something with and send them back, or to get some state, create a new instance of one of these components, send it to the ledger for execution, and your stuff happens. So you've kind of got these like three distinct layers, right? You've got your low level state stuff, like your state kernel, I suppose. Then you've got your state primitives, your application primitives, which are hosted data resources and token specifications and all that kind of stuff, and anything that you deploy. And then you've got your application logic, which is your Twitter DAP or your DAP store JavaScript logic or whatever. And that's basically the state and execution model. And then obviously underneath you've got all the Cassandra consensus magic that makes sure that all of this runs as it should. Sorry guys, I still got a bit of a cough from this COVID. It's gone. I'm clear. All my lateral flows and are now negative, but still got a bit of a tickle. How do I plan to communicate about this? So I'm actually working on a bunch of presentations too at the moment. One of which is going to be ready quite soon. And because there's so many kind of bits to Cassandra, right? You've got the Cassandra local consensus, then you've got the Cassandra cross shard consensus, which looks a little bit like Cerberus, but also doesn't at the same time because it's kind of evolved a little. Then you've got all the state vote stuff, the state model. Then you've got how do you efficiently vote between shards and all that kind of stuff. Then you've got the execution model that runs asynchronously to all the consensus process. Then you've got these kind of state primitives and things, and just all these bits and pieces that to try and cover them all in like a couple of hours of presentation. One would be rushed, and two, everybody would probably be like brain fried within a couple of hours. So what I'm intending to do is split them down into like hour-long sessions, and try and build these presentations as some kind of working example, right? So in the case of the first one is going to be it's just basically going to be talking about the fundamentals of the Cassandra consensus without any sharding or anything, right? So there's no sharding, there's no state stuff, there's no execution stuff. It's just the kind of raw strip back what happens in Cassandra hybrid consensus. And the working example there is actually going to be, okay, if you take a Nakamoto consensus, Bitcoin consensus, what are the things you have to do to that Bitcoin consensus, that Nakamoto consensus, to end up at Cassandra consensus? Because you're starting from Bitcoin, which is purely probabilistic consensus. It has probabilistic safety and weak liveness. And what we want is to get to Cassandra, which is a probabilistic deterministic hybrid that has a weak safety guarantee and a weak liveness guarantee. And both of those things are kind of desirable, let's say, right? And the reason the safety is weak is because it's impossible to have a strong safety guarantee and any liveness guarantee whatsoever. So trade out some of your safety guarantee so you can have a liveness guarantee. Now, when I say the safety guarantee is weak, it doesn't mean that like things just go bad. It's like it's weak because you're going from a strong safety guarantee, deterministic guarantee, to a probabilistic guarantee under a liveness condition, and then once that's resolved, you're going back to a deterministic strong guarantee again, and then when something else goes wrong with liveness, you revert into a weaker probabilistic safety guarantee until you fix the problem, and then it reverts back again. So that's why I say weak. But actually that example is quite simple in terms of the number of steps to get from Bitcoin Nakamoto consensus to the fundamentals of Cassandra consensus. It's like 5 or 6 steps, and it doesn't get too deep. So that's like the first one I'm going to do, and then I'll talk about like how do you put them together so you have cross shard stuff and have a working example there, and just kind of build it up over time in these like hour-ish long presentations of, okay, here are a number of steps where we go from what we had previously and we build it out, and then you can hopefully start to build a bit of a picture, even if you're not too technical. I'll put some diagrams and stuff in there as well, so hopefully you'll be able to build a bit of a visual picture of what's going on and at least have a bit of a deeper understanding about what Cassandra is doing, where it's different to everything else, and how you put the building blocks together piece by piece until you end up at something that can do the demonstrations that we're just doing. So that's kind of the plan over the next 3 or 4 months. So these will be like my versions of Piers's podcasts, I guess. Instead of DeFi download, we'll have blockchain builders or something. So yeah, anyway, so there's my thing. Now what I'm going to do is I'm going to stop this stream about now. Then I'm going to download this stream from Twitch when it's processed. I'm going to push it up onto Flexathon, and then I will share the link. Well, I'll share both links on Twitter, because if the Flexathon stuff goes down for any reason, then there's always the alternative. So I'll share them both. Hopefully that won't take too long. And this will be a good test as well, because this stream is quite long. So let's see how it does with a big chunky stream while it's doing Twitter imports as well, of course. Cool, guys. So thanks for joining my impromptu Twitch stream. I hope you're all sufficiently mind blown, and I will see you all on the flip side.